Welcome everyone. This is a very quick, very high-level introduction to stress analysis using Autodesk Inventor. I'm going to do a couple of follow-up tutorials after this, but I just wanted to do a really quick video to kind of explain this. I know a lot of you have given me a lot of questions about using stress analysis in your projects for SE 101. I just wanted to address some of those and give you guys some guidance and some give you some ideas on what's going on when we're trying to do stress analysis. It's really important part of engineering to be able to do this, but I know that most of you guys have not had calculus or the higher level maths yet necessary to really understand what's going on. So I'm just going to go over it from really high level so that we can start using it, even though we haven't gotten to that point yet where we can actually really understand what's going on from the mathematical perspective. So when we're talking about physics, one of the main branches of physics is mechanics. Mechanics is basically the study of forces and motion. Up to this point, you probably have done in your physics courses in high school or your first year engineering school, you've done a lot of mechanics of rigid bodies. So these are motion where you're assuming that the thing that you apply the force to does not deform under the force. Well, in real life, we can't make that assumption, and everything is actually a deformable body in some form or another. So we have to think about the mechanics of deformable bodies. When we think about the mechanics of deformable bodies, we have to think about how the material will react when we're applying forces. So here's a good example, a couple of these figures. So a rigid body would just be so that this bar and the two balls are the bodies that the forces are applied to, and you're assuming that there's no deflection or deformation at all in the materials. I said in real life that's a bad assumption. Realistically, we're going to have a deformable body where our materials are going to react to forces applied to the different parts of the system. One of the main ways we can analyze that, it's really, really complicated mathematically, but we can do it in a pretty simple way by using finite element analysis. The main important things that we want to remember are, if we're looking at just a random piece of the material, that we have different forces applied to it from different directions. We have different shears and forces and different things like that, but right now only think about the idea that if you apply a force to this cube, it's going to deform. How it's going to deform, one of the ways we can look at that is looking at a stress-strain curve. And so we have two regions in our stress-strain curve. We're not going to talk about the details of this because it can get pretty complicated. But essentially what we have is what we call an elastic region, which is linear. And in the elastic region, think of it like elastic in your clothes. If you were to pull it, put force on it, it would deform, and you let it go and it goes back to the original shape and size. Well, we don't always have that. If we take it past that point to the plastic zone, then it will actually permanently deform and it will never be able to actually go back to the original size and shape. So we have to think about that, and we have to prevent our system from going into the plastic zone in order to design it well. Because when we start going to the plastic zone, it's on its way to failure. So when we're designing and we're modeling our systems that we're doing in this course, we want to make sure that our systems are robust and strong and that they'll survive. The two most important things that are usually done with finite element analysis are to analyze stress. So stress is defined as the force divided by the area that it's applied to. So you can see how this interesting stress distribution is in this beam here. This is really, really important for us to look at because this tells us where we have points where the force is locally is so high that we actually can initiate a failure in the material. We can also need to look at deformation, which is the second thing right here, because we need to be able to tell if our system that we're making is strong enough to actually hold up the amount of weight that's on it. Here's an example of a system that we might do finite element analysis on. One of the things we would really, really like to do is to figure out which parts of this we can actually do finite element analysis on and which makes sense, which I will talk about in the second part of this video, so stay tuned. Thank you for your time.